Hello and welcome to today's maths lesson. My name is Robert and it's great to be here. It's great to be able to do this. It's great to be able to bring learning to you. In today's maths lesson, we're going to continue talking about analytical geometry and we're going to be talking about tangents and angles. And so let's get straight into it. If you guys turn to the board with me, today we're going to be talking about tangents. We're going to be talking about angles, but before we do that, we're going to talk about lines because, in essence, a tangent is a line. It's just a special sort of line. And so we're going to recap what a line is. A line, like we discussed in previous lessons, has got the equation mx plus c. Y equals mx plus c, where m is the gradient and c is the y-intercept, the y-cut, where the line cuts the y-axis. And so what we're going to do now is we're going to do an example of a question with a line and with a circle and see how that plays out, because what we're going to have to do is we're going to have to use some of the circle geometry that we learned in geometry to be able to solve this question. And so let's get to it. Our question says there's a circle, x squared plus y squared equals 10. In this case, because it's not x minus 1 squared, minus 1 would have moved my circle to the right 1 unit. In this case, it's just x squared. And so that means the center of my circle is at x equals 0 and y equals 0, which is the center there in my Cartesian plane, the origin. And they tell me that there's a chord drawn, AB. They tell me that the point D is the midpoint of my chord, and that's important. We're going to see why that's important later. And what they want us to do is they want us to calculate the equation of this line AB. Now, I'm going to move the sketch to the top of the board there so we have a little bit more space to work. We've discussed this quite a few times, but when it says determine the equation of something, a parabola, a line, a hyperbola, a circle, I'm always going to start by writing my standard form. That standard form is y equals mx plus c. What do I need to find? I need to find the gradients, and I need to find the y-cut. Now, it's very apparent that from this sketch, I can't see the y-cut, so probably what I'm going to do is I'm going to calculate the gradient, and then I'm going to sub in the point to calculate or to determine what the y-cut is. All right. Now, I still don't have an idea about how to do this. I need to work out the gradient of this line. Once I know what the gradient is, I can sub in the point. But how do I calculate the gradient of that line? It looks like it's just a random line. This is where we're going to have to remember our circle geometry and specifically this theorem. Now, this theorem here says that if we have a circle on the left here, and there's a line from the center of the circle, and there's a chord, and the line from the center of the circle cuts that chord in half. What that means is that the line from the center is perpendicular to the chord. Now, let's see how that's going to help us with this question. So let's go back to the question. What we've known, what the question told us is that that is the midpoint of this line. If I draw a line from the center of the circle to the and I don't know what quite happened there. If I draw a line from the center of the circle to the center of the midpoint, what I know is that this line is perpendicular. Now this is great because I don't know if you guys remember, but we spoke about perpendicular lines in a previous lesson. If I can work out what the gradient of the line from the center is, then I can work out what the equation of line AB is, because those are perpendicular lines, and then I can go from there. So the gradient formula is this. We discussed that in previous lessons. I want to work out the equation of the red line, which is from that point to the center of the circle there, which is 0, 0. And so what did we decide? I'm going to go y minus y, so I'm going to go that y value minus this y value, minus 1 minus 0. I'm going to go that x value minus this x value, minus 2 minus 0. I'm going to put that into my calculator, and you guys can trust me on this. The answer is equal to 1 over 2. Now, what have I done? I've gone and worked out the equation, and let me just erase a little bit here. Oh. It's shifted to the other side. All right, that's perfect. I'm going to pick it up on this side. I'm going to erase that there a little bit just so I have a little bit more space and change the color of my pen. I've gone and calculated the gradient of that line as a half. Now, this gradient of line AB, we decided because it's perpendicular lines, the product of the gradient is always going to be minus 1. But what did we decide we were going to do in the previous lesson is all I'm going to do is I'm going to take the gradient of the one line, I'm going to flip it over, I'm going to change the sign, and that's going to be the gradient of the line that's perpendicular. So the gradient of line AB is going to be this gradient flipped over. So it's going to be, instead of 1 over 2, it's going to be 2 over 1. And I'm going to change the sign to a negative, because a negative times a positive is going to give me a negative answer. Now I want the answer, my product must be equal to negative 1. And so, excellent. Now I have my gradient, minus 2x. All that remains for me to calculate is what is the y-cut. But remember when we did this in previous lessons, what we discussed is that the whole idea, and let me choose my eraser here, the whole idea about functions is it's all about input and the resulting output. And so if minus 2 is the input, minus 1 is going to be the output, and so that's what I'm going to do. I'm going to put in minus 2, I'm going to get out minus 1. Let me do that in red. So y is minus 1, x is minus 2. Let me go back to blue. And now all I'm going to do is I'm going to solve for c. I'm going to simplify a little bit, so negative 2 times negative 2 is 4. I'm going to subtract 4 on both sides, and if I do that, I get c is equal to minus 5. Excellent. And so my equation ends up being minus 2x minus 5. So let's move on to the next part of this question. We can see I have the equation of my line, and it asks me what are the x-coordinates of A and what are the x-coordinates of B. So here I have my circle, here I have my line, and actually what they are asking is what are the intersection points of my line and my circle. So remember, when we did intersection points, we had to solve simultaneously. And so the way that we're going to solve simultaneously is there I have y, here I have y, but y is equal to this. And so I'm going to take this whole section and I'm going to sub it into y. If I do that, I'm going to get x squared plus y squared, but now y is equal to minus 2x minus 5, and so I'm going to go and put, instead of going y squared, I'm going to go minus 2x minus 5 squared. This is equal to 10, and this gives me an equation where I can solve for x. Again, what's crucial is when we do something like this, I write this out twice. So this is not 4x squared plus 25. I'm going to write this out twice, and then I'm going to do the distribution of multiplication, which we've called FOIL in the past. I'm going to get x squared plus 4x squared plus 10x plus 10x plus 25 is equal to 10. And I'm going to collect like terms, so there I'm going to get 5x squared. That's going to give me plus 20x I'm going to take that 10 to the other side, and I'm going to get plus 15 is equal to 0. And I'm going to leave the question there. You guys can solve it on your own at home now in the ad break that's to come. I want you guys to solve for me what are the x values for A and for B. So we're going to go to an ad break now, and we'll see you guys soon.